Hello everyone and welcome to Frogs, Fleas, and Painted Cubes 4.2. We'll be working from page 73 in your textbook today. Our learning target, I'll be able to correctly associate a jump to a parabola. 4.2 ACES questions begin on page 82. We'll do 6 through 11 and 12 through 17. Ask you to identify different parts of a parabola. You don't need to tell me what the vertex is. And then 31 and 32. Measuring jumps. Hey, look, there's a frog. Finally starting to figure out why they call it frogs, fleas, and painted cubes. So we're going to compare quadratic functions. A quadratic function is in the form of ax squared plus bx plus c. And as you probably already know, many animals are known for their jumping abilities. Most frogs can jump several times their body length, as can cats. Fleas can jump off of whatever fleas live on and jump on other animals like cats and dogs. And then we have people that can jump really well too. Winners of slam dunk competitions, Michael Jordans, people like that can jump as well. So let's take a look at 4.2 here and compare some different equations. Part A tells us, suppose a frog, a flea, and a basketball player jump straight up. Well, we won't say exactly straight up because they wouldn't completely be a parabola if it was perfectly straight up. But for argument's sake, they jump straight up. Their heights and feet after t seconds are modeled by these equations. Frog is h equals minus 16t squared plus 12t plus 0.2. The flea is h equals negative 16t squared plus 8t. And then the basketball player is h equals negative 16t squared plus 16t plus 6.5. Notice the similarities and differences in each of these equations. So use your calculator, and again, I want you to use the color calculators for this because it's going to look a lot nicer for you if you do that. To make the tables and graphs of these three equations, look at heights for time values between 0 seconds and 1 second. And in that table, use time intervals of 1/10 of a second. So you should have 0 seconds, 0.1, 0.2, 0.3, so on and so forth till you get up to 1.0. Then, what is the maximum height reached by each jumper? And when is that maximum height reached? How long does each jump last? Then for what are the constant terms, 0.2 and 6.5, 0.2, 6.5, these are your C values. What do these tell you about the frog and the basketball player? And how is this information represented on the graph? Then for each jumper, describe the pattern of change in the height over time and how that pattern is reflected in the table and the graph. So really what you're going to be doing is just comparing these three different equations. As I said at the beginning, look for similarities and differences here. It talks to you a little bit about the constant terms. What does that mean? Where are those going to be? How is that going to affect the jumps in the graph? Then part B, we are going to skip this, and that's it for 4.2. Just being able to see the pattern differences in different types of equations. 4.2 again is 6 through 11, 12 through 17. No need to tell me what the vertex is, and 31 and 32. Look forward to your comments and questions in class.